We travel back in time to 4.6 billion years ago to see the moment when our solar system was born. Wow, there's nothing that looks like a star or a planet. So far, there's just a giant cloud of dust. It's called a nebula. These are molecules of hydrogen in heavier elements, along with ice, left there from a previous star. But this cloud isn't dense, so it can't turn into a star or a planet. But then a blast wave comes here, maybe even several. There's a supernova explosion a couple of light years away from our nebula. This is when a giant star burns off its fuel, then collapses under its own weight. At this point, a boom of such force that its light can be seen dozens of light years away. The blast wave from a supernova reaches our nebula like a sea wave. It hits the dust cloud, causing it to shrink and become denser. Then the nebula gained a common center of gravity. It attracted more and more dust particles to itself. This put a lot of pressure on the nebula's core. It started spinning. And the greater the mass of the central cloud, the faster it rotated. The particles inside the core collided faster and more frequently. This raised the temperature of the nebula to several thousand degrees. At this point, a protostar appeared. It was a young and unstable sun. When the temperature in the nebula's core reached millions of degrees, nuclear reactions began there. The cores of light elements like hydrogen and helium hit each other and fused into heavier elements. Let there be light. 4.5 billion years ago, the protostar evolved into a stable sun, but 30% dimmer than we have it now. There's also a giant cloud of dust left behind. This is the remnant of material that didn't take part in the creation of our star. Now you can see the larger objects in this cloud. Heavy elements and dust began to pile up, forming protoplanets. At this stage of our solar system's existence, there were about 100 protoplanets, ranging in size from lunar to Martian. Back then, there was nothing but total chaos. These protoplanets didn't have clear orbits, and they began to collide with each other. Some crashed into a pile of debris, creating massive explosions. Others collided tangentially and simply changed their trajectory. In this cosmic billiards game, the largest protoplanets won. They literally ate the smaller debris and got bigger and bigger. The chaos didn't stop until about 100 million years later. You can see some nearly formed planets: Mercury, Venus, Earth, and Mars. Our home planet now looks more like a lump of lava. The constant bombardment of the surface by various asteroids has heated the planet greatly, but now it has begun to cool down. Everything went quite well until an unknown villain appeared on the horizon. It's Theia. It's a hypothetical planet the size of Mars, formed around the same time as the other planets. And now, it's spiraling toward Earth, ready to hit it. Bam! As a result of the impact, a huge chunk of our planet was knocked out into space. Theia herself was blown to pieces. Its core merged with the core of the Earth, while the rest of the material remained in our planet's orbit. Gradually, the debris from both planets began to collide with each other and merge into a large cosmic body. When the dust settled, the Earth received its satellite, the Moon. Another hypothesis for the formation of the Moon suggests that Theia was much larger than Earth. It only lightly scratched our planet and continued moving without losing its material. And the Moon was formed almost entirely from particles of our planet. As proof of this hypothesis, we have samples of lunar soil delivered by the astronauts of the Apollo mission. It turns out that the lunar soil is very similar in composition to Earth's crust, and it could only have gotten there as a result of some violent event. Gas giants like Jupiter, Saturn, Uranus, and Neptune formed a little later and further from the Sun. These planets are literally balls of gas. There's no solid surface. If you step on Jupiter, you'll fall until you reach its core. These guys couldn't get a solid surface for several reasons. They formed later when other planets took over the metals and silicates. They also all originated beyond the frost line. This is a hypothetical point somewhere beyond the orbit of Mars. The sun doesn't heat the area behind this line enough for water to be in a liquid state. So there was a tremendous amount of ice in the remaining clouds of gas. 3 million years after the birth of the sun, these building materials started to pile up and build mass, becoming Proto-Jupiter. Within a couple of million years, this ball of ice could reach a mass about 50 times larger than Earth. And the heavier it got, the more gas from the disk it was able to accumulate. In a short period of time, Jupiter absorbed almost all the material from the disk of gas near it and accumulated about 318 Earth masses. Jupiter had a very strong gravitational field, and it wreaked havoc on all objects in the area between Mars and Jupiter. Protoplanets collided there much more often, causing them to collapse. As a result, we have the asteroid belt. These are fragments unable to reassemble into a full planet because of the intense gravity of the gas giant. Saturn, the next of the 4 gas giants. It's 3 times smaller than Jupiter. It's thought to be so small because it's even farther from the Sun, about 10 Earth-Sun distances. And it began its formation even later when Jupiter left almost nothing of the gas disk. But Saturn got another distinguishing feature: the rings. They're so wide that you could fit 21 Earth planets on them, and they're as thick as a 5-story building. We still don't know how they were formed, but there's 2 main hypotheses. So Saturn has 82 moons discovered so far. There may have been one more, but it was destroyed in a wild collision. The moon was shattered into small fragments that began to orbit the gas giant. These fragments, in turn, collided with each other and shattered again. Gradually, debris the size of a skyscraper turned into small grains of sand. Yep, Saturn's rings are made up of cosmic dust and ice. Then come Uranus and Neptune. They are much smaller, only 14 and 17 Earth masses. It is believed that they couldn't reach the size and weight of Jupiter because of the strong solar wind. It gradually blew the gas disk outside the solar system into interstellar space. So there were much fewer building materials for new planets. When Uranus was formed, it experienced a catastrophic collision with another protoplanet, and probably a very large one. The collision caused Uranus to fall on its side. All planets have their axis of rotation pointing upward, but the axis of Uranus is pointing toward the Sun, so it looks more like a rolling ball. Only it's rotating retrograde. That means it's spinning against its own motion. It's like a car driving forward, but its wheels spinning counterclockwise. Behind the gas giants is the Kuiper Belt. This is the area beyond the orbit of Neptune. This is where the asteroids, dust, and ice were left after the solar system formation. It's similar to the asteroid belt between Mars and Jupiter, but it's about 100 times heavier. Knowing how our solar system was formed, let's see how it might be destroyed. The Sun has a lifespan, just like any other star. Right now, it's about halfway through its life cycle. Every second, the Sun turns 4 million tons of matter into solar radiation. Gradually, it'll run out of fuel and begin to burn heavier elements within it. This will increase the temperature, luminosity, and size of the star. In 1.1 billion years, the Sun will be 11% brighter than it is now. The seas and oceans on Earth will begin to evaporate, and our planet will heat up more and more. In 3.5 billion years, its brightness will be 40% higher than it is now. Conditions on Earth at that point will be similar to what we have on Venus now. Life will be simply impossible. In 7.8 billion years, the Sun will start burning hydrogen in its shell. This will cause it to expand and become a red giant. It'll be about 256 times larger. At that point, the star's outer shell will be exactly where the Earth's orbit is now, but it'll lose its mass. So there's a possibility that our planet will migrate a little further away from it. But it won't matter, because life on Earth won't be able to exist for several billion years already because of the high temperature, and a strong solar wind will simply blow our atmosphere away. Then the thermal pulsations inside the star will tear off the outer shell of the Sun. This shell will turn into a planetary nebula, almost exactly like what we saw at the beginning. And all that will be left of the Sun is a white dwarf, the size of the Earth, which will fade away for a few billion years.
Mercury, about 3.8 billion years ago. A huge asteroid is about to collide with the planet. Boom! Fragments are flying in different directions, along with the blast wave. When the dust settles, we see a crater almost the size of Lake Ontario. The most interesting thing here is the shape of the crater. It looks like a spider. A round body in the center, and a bunch of legs that spread out from the crater in different directions. But the strangest thing is that the spider's legs don't quite line up with the center. Scientists can only guess how such a landscape was formed. Some think that the picture of the spider appeared there much earlier, and the meteorite falling almost into its center was just a coincidence. But we still don't have a clear explanation of how such scars could have appeared on the surface of Mercury. Another mystery about Mercury is how it was born. One theory claims that the planet used to be Venus's moon, but over time, it succumbed to the sun's gravity. The star literally ripped Mercury away, and the little planet began orbiting it. What might prove this theory is the rotation periods of Mercury and Venus. Mercury is gradually losing its rotational speed. One day on this planet now equals 58 Earth days and continues to increase. At the same time, after losing its heavy load, Venus has started rotating a little faster. Another theory says that Mercury collided with Venus shortly after the appearance of the solar system. At that time, Proto-Mercury was slightly larger than the planet we're familiar with these days. But then, Mercury lost part of its crust after colliding with Venus. And a little later, Venus collected this debris. But scientists still can't come up with a definitive answer as to how Mercury was formed. Uranus, a gas giant, 18 Earth-Sun distances from our home. This planet seems calm compared to other giants, like Jupiter with its Earth-sized storms. And still, Uranus has something unusual to boast about. This dark spot, for example, was detected by the Hubble telescope in 2006. At that time, it was almost twice the size of Alaska. A few years later, bright spots appeared there. It turned out that they were methane clouds that moved across the surface of the planet at a speed of 300 miles per hour. But we don't know what exactly causes such storms on Uranus. Maybe we can solve this secret by looking at another mystery of Uranus. This planet rotates while lying on its side. If you look at the axis of our planet, you'll see that it's vertical and only slightly tilted. It's the same for most of the planets in our solar system, but not Uranus. Its axis is almost horizontal and pointed toward the sun. One of the poles of Uranus is fully illuminated at almost all times. The polar day on the planet lasts for 42 Earth years. When the tilt of Uranus's axis changes, the polar day starts on the other side of the planet. The other pole plunges into darkness for 42 years. This change of seasons can cause severe storms on the planet's surface. But why exactly Uranus lies on its side is unknown. Perhaps billions of years ago, the gas giant collided with several asteroids that were about to become a young planet. Such a protoplanet, similar in size and weight to Earth, could have tilted Uranus after crashing into it. But it's still just a hypothesis. Now let's go to Jupiter's moon, Europa. The big mystery here is whether there is life on this moon. Scientists don't deny such a possibility. All you see on the moon's surface is ice. The stripes you may spot are actually long, wide cracks. For a long time, scientists thought this moon was nothing more than a block of ice. But now, they think there might be liquid water inside. The core of Europa is heated by the tidal forces of Jupiter. This warm core melts the ice around it, so there really could be a huge ocean under the ice crust. Since water is the basis of life, different microorganisms could exist there. But we would only find out if we sent a probe there. We would have to drill through 24 miles of solid ice and start searching in an ocean twice the size of all water reservoirs on Earth. Look at Saturn's moon, Titan. It's the second largest moon in the solar system. It's 50% bigger than Earth's natural satellite. It's the only place in our solar system, other than Earth, where liquid water has been proven to exist. But the most interesting thing about Titan is its atmosphere. It's 250 miles thick. This distance is almost 40 times greater than the average cruising altitude of commercial planes on Earth. And it's 95% nitrogen. For comparison, Earth's atmosphere is 79% nitrogen, which means they're quite similar. The mystery is that no one knows how this atmosphere appeared there. One theory suggests that many years ago, meteorites hit Titan's surface almost non-stop. Massive rocks collided with the crust, raising the pressure and temperatures on the moon. Under such conditions, the ammonia in the air decomposed into nitrogen and hydrogen. The heavy nitrogen fell on Titan's surface, while the light hydrogen rose and flowed out into space. But some scientists dispute this theory. Another mystery of the solar system is the hypothetical star Nemesis. and whether it really exists. If you look at all the stars of our galaxy, most of them are paired, which means that two stars orbit around each other. Statistically, the Sun must also have a companion. So, some scientists have made an assumption that the largest mass extinctions on Earth were related to some mysterious object in space. They hypothesized that there was a red dwarf somewhere within 1.5 light-years away from the center of the solar system, and every approach of this dwarf star to the asteroid cloud disturbed these space travelers. Every time it happened, several asteroids began their journey toward Earth and caused a mass extinction. But this star hasn't yet been discovered, and many scientists question this hypothesis. Now let's look at the very edge of the solar system. A photon of light has to travel 1 year to get here. Scientists believe the Oort cloud exists in that area. It's a hypothetical region where tons of asteroids and blocks of ice gather into clouds. It's the furthest place where the sun's gravity still works. Presumably, this spherical cloud wraps around the solar system. This is the region where long-period comets are thought to originate. They fly all the way through the solar system and then return to the Oort cloud. This journey can take thousands of years. Even more exciting, there could be a gas giant called Tyche in that region. Some scientists say it might be 4 times the size of Jupiter. So far, no research has confirmed its existence. Although the Oort cloud is still considered hypothetical, some scientists believe that comets from that area are responsible for the major mass extinctions on Earth. Now let's go beyond the borders of the solar system. There, 1,500 light-years away from Earth, there's the closest to our home planet black hole. Black holes are the most mysterious objects in the universe. They're so heavy that they attract not only matter, but also light. Even more, they slow down time. Once something gets trapped in a black hole's gravity, it never escapes. Light and matter gradually settle near the event horizon and soon disappear into infinite darkness. Time flows differently here. 1 minute near a black hole can be equal to weeks on Earth. The biggest mystery is what exactly is inside a black hole. Some speculate that there's nothing but crushing pressure that destroys anything that gets there. Others say it might be a portal to another dimension or a wormhole to another place in the universe. If it was true, white holes would exist as well, as exits from black hole portals and wormholes. But no white hole has been found so far. Now, how about going to the hypothetical border of the entire universe? It's called the Eridanus supervoid. If you look at the map of the universe, you'll see an empty cold spot about 1 billion light-years wide. The entire Milky Way galaxy is only 100,000 light-years across. The main mystery is how the spot appeared. One theory says this void is the scar left by the collision of 2 parallel universes. Imagine that universes are giant bubbles, and one day, 2 of these bubbles collided. That's when the parallel universe ripped several galaxies out of our bubble. So far, this is the only explanation for how such a huge cold void could appear in our universe. We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes, but it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own. And our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system. But these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot, you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth. And it gets 22 times more energy than we get from the Sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the Sun. and it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy. So it belongs to the class of super-Earth planets. Such planets can be rich in water ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live. But because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the two nearest planets are too hot. But the third planet looks more promising. L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about a third of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. The presence of water is the main condition for the emergence of life. But we can only guess where the water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super Venus class, L9859e. It's a rocky planet 3 times the size of Earth. The Super Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, the stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot at a perfect distance from the star. Not too close so that the planet isn't too hot and the water there doesn't evaporate instantly. And not too far away, so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet F in this star system, located right in this sweet spot. This super-Earth candidate is 2.5 times heavier than our home planet. So we have hopes that it's a rocky world, just like the other planets in this star system. The weight of planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. The planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there's a slight drop in the star's brightness, that's when a planet has passed between us and the star, like this dot. We have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,715 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk. And they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts. But it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signals too. But so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us because we're always looking for life outside of our solar system. And super Earth-class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called super-habitable. So some scientists think that Earth is a good place for life, but not the best. Super-habitable planets would have to be 30% larger than Earth and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This in turn would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This would make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the Sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the Sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy, besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the Sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, they expand and either absorb the planets around them or burn them up. One last thing, let's find planets in this pile that are in the habitable zone of the star. And voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them.